Hello and welcome to the Tails third technical demo. This time we're going to be talking about features and the feature loader, which is a side application I use to get the mapping data all in and managed. Right, first off, let's talk about what a feature is. If you take a look here, I've got the Tails map screen with no events shown. A feature is one of these items that we can select, or at least within the context of how I am using a feature. With regards to mapping data, features can also be things like pins, but let's ignore that for the moment. We're just talking about selectable areas. So that's the Europe feature, and we have an Asia feature and an Africa feature, the continents of the world. If you zoom further in, the resolution increases, and we have a UK feature, France, Germany. These are inside the Europe feature, and that's an important thing I need to encapsulate because, for example, this particular event here, it happens in Germany, but if you zoom out, you would also like to see it happening in Europe so that it can reflect all the way down. The resolution can increase further. I've only got limited mapping data at the moment, but you can see how all of these individual features are individual features and how they relate to each other. So what does this mapping data actually look like? Well, I've got an example of GeoJSON, which is taken from a online website. I think this might have been Ordnance Survey. This particular one is a file containing the countries of the world. It is quite large, you can see by this very narrow little scroll bar. I'll flick you through some of the bits so you get a feeling for it. First off, you start off with a feature collection at the top, which then has a collection of features. Each one is a feature with a geometry. The geometry has a type, which can be polygon or multi-polygon in practical terms, and then it's got the data for what's inside. There are lists and lists and lists of coordinates, which are latitude and longitude. Depending on what type it is, it changes what's inside the coordinates. The exact details don't particularly matter. There is also a properties collection, which is essentially your metadata. And wow, does this come with an awful lot of metadata in various different languages. I only need a subset of any of this. And then it continues. Feature, feature, feature. We have a multi-polygon here. But looks very similar, and it's got all the properties. That is what a GeoJSON file looks like. It is the most standard data set I can see, data structure I can see being used for mapping data on the web. And the mapping tool I am using, called OpenLayers, uses for its structures. So if we go back to Tails, let me open up the dev tools. Let's refresh. In fact, we're probably going to have to do a different kind of refresh. Let me clear all of the memory. You see, I have, where are we? Local storage. I have saved the country data here already so that we don't have to do so many trips to the API. In fact, you can see the data here. Does it look familiar? Oops. Let's take that out. We'll put that into another Notepad++. Tell it we are looking at JSON, run, the format. Shouldn't take too long. And sure enough, this should look very familiar to you. We have a feature collection, features, type feature. I've got the properties here coming first. It doesn't matter what the order is. Geometry, multi-polygon, off we go. You can see I've got a much smaller set of properties, only the things that I need that are relevant to the application, and it continues. So this is what you're looking at here, is what Tails serves to the client, where the mapping tool, OpenLayers, takes that JSON and then draws the features onto the map space for me. I don't do the drawing myself, I let the tool handle that. I just make sure I've got all the feature data correct. So now we've got an idea of what a feature is and how the structures are. Let's look at the loader. There's an awful lot of mapping data in the world, more than I can reasonably collect. In fact, the data which I've already got took a fair amount of time to put together. Given that there is an awful lot, particularly when you're talking about things like counties, cities, hell, you can even go down to streets and developments if you really want, then all over the world, it's going to be too difficult to put it all together. So it will be a project that improves over time. And also feature data does sometimes change. It needs to be managed by a tool, and the tool I have for it is the feature loader. Now it's only what I need at the moment, and I have recently found that there is a bug in it. But we're going to go through what I've got right now, and you can get a feel for how things work. We have the data context, which is a entity relationship data context, which is just used for the manual database access. We have a feature repository, which handles the tails context. So I've divorced how I'm actually getting the data from the rest of the application. And the rest of the application essentially sits here in core. It's quite simple, as well as the domain. Let's take a look at the modeling in the domain. So I have this project, tails.domain, which has all of the main entities for Tails. Then I have a folder for GeoJSON, which really should be renamed because it's not entirely JSON dependent, where we have the feature. That's the main guy that we are talking about, a feature that you have seen in here. And there are some similar looking properties here, not all directly the same, because some of these collections are used in business logic and not just in serializing and deserializing JSON. But there are some other objects which are more familiar from what you've seen from the GeoJSON files. Polygons. Some inner workings about how polygons work. They have exterior rings and interior rings, and they work in different directions, and all sorts of little details. And the properties which I want to preserve and serve. The next most important bit here are the deserializers. So I have put together, they're all based off this little interface here, where you deserialize a particular J token and you give it some properties. And the serializers work very similar as well. So let's start from the top. You have a feature collection deserializer. Sure enough, it requires a feature deserializer, which makes sense. The feature collection has a load of features inside, and the way it works is it looks for the features attribute and then runs the feature deserializer on each one, adding it to a collection called features. Looking at this, you have a features property with a collection of features inside. So it just follows along what is the standard data structure for GeoJSON files. And the rest work basically the same with a couple of little tweaks. The properties need to be changed to after they have been deserialized based off of the context of what I'm doing. More on that in a minute as we go into the feature loader itself. But yeah, it's straightforward, to be honest. There were tools that could be used to do this automatically. I looked at a couple of NuGet packages. They're full of holes. They do circular dependencies and they run into all sorts of problems. And in order to configure them requires more code than just doing it myself. It's actually quite a simple thing to do. And just to show you, serializers, which is what turns the feature objects that I have and turns them into your GeoJSON to be sent down to the client so that the mapping tool can draw them. This is what they do, and look at that. It adds the appropriate properties. It's a feature collection. It goes through, makes a J array and serializes each feature inside, and each feature serializer uses other ones. And then you add it to the collection. And this is what you end up with, this particular version, because of course I've got my specific properties all set up. Okay. Moving on to the feature loader itself. The feature loader sits here. It has its own project. It has a few files in it, a couple which are not particularly interesting, an overridden data context, a repository file which just does the actual data access with the context, so I can divorce the main logic of the application from the repository, and this guy core who does the real work. Have a quick look in program. It is a console app, and so it's just a little tool that works. You have some default properties in here which I just use for it's my own personal use. Ask a couple of questions. I need to know the zoom level that the features will pop in at, and then give it a list of features which might be its parent. So if I'm giving all of the counties of the UK, I also give it the UK as a parent that it might be a part of. So every time it checks one, every time it adds one of these counties, it'll see if the polygons are inside any of the parents in order to make sure the structures are put together right. And that's where I seem to have a bug as well at the moment. But let's go into the core to see it actually working. So we've got a few guys here. Much as you might expect, I've got to read that file and then deserialize it. I'm going to test the polygons, and then I'm going to save things to the repository. Quite straightforward, much as you might expect. We've got one public method here where we load the features into the database, and I get the file content. I deserialize the object from the file, here we go, and then connect the features to the parents and save everything from there. Pretty straightforward, really. I need to do some more things to marry the features up together. Features have keys as well as IDs. I need to make sure everything is preserved if I do update. For example, if I'm updating the county data for the UK, the events that are already in there need to have their locations preserved, and I've got to marry those up based on keys and perhaps even the polygons. But problems for the future, I haven't needed to run into that issue yet, so I haven't resolved it yet. The feature data is served to the application through the API, where I have a features controller. The features controller uses a feature manager class, which upon starting the API loads all of the feature data into memory. So it's a heavyweight. It does mean the startup time is relatively slow, but at the moment still it is small enough to run on the lightest applications that Azure allows, so I can keep it nice and cheap for myself. But of course, it then serves all the feature data very, very quickly. When the map pane is moved on Tails, let's bring this up. When the map pane is moved, the view screen is sent to the API to see what features need to be sent back. Now, it doesn't really matter much for the continents, but as you move into the countries, it's more important. The US, for example, would not be sent. In this particular case, it actually is sent. The countries and the continents are sent early, and then they are cached on the client, so that the countries and continents which are seen the vast majority of the time are just loaded on the client, and it doesn't have to hit the API anymore. It was an important performance feature before I put anything live and incurred some titanic, horrible hosting cost. But if we look a little bit further, it's only the countries and continents that have that. These counties, we can even inspect this. So as I move, unfortunately the collection, you can see only some of the counties have been sent. But if I move it here, so only a few of them will be sent again, we have this call to the features controller, you can see there, zoom level 6, and a coordinate list, which is the viewport. If we take a look at this particular result, we can see we are not going to have, let's say, Cornwall will not be there, will it? No Cornwall. Proving that it's only sending some of the counties down. In fact, perhaps if I move here, we look at this second one. Let's format it once more. Let's go to the top, find, oh, we already had it, Cornwall, and now it is sent. As mentioned, the site caches the continent and country data into the local memory, the local storage for the browser. You can see we have a few properties here. The date that it was saved last for the zoom level, which is important in case I in the future want to override with fresh data, and the zoom level with the actual features that are saved. So these are the continents for zoom level 3 and the countries for zoom level 4, of which there are many. We can see that working properly. If we move around, there's no hit to the API. Zoom in a bit, no hit to the API. Oops. But zoom in a bit more. Here we go. We've hit the features. Works nicely. Should keep things performing relatively well and my hosting costs down. Features are also present in the database. This is important so that I can attach the events to them directly. Whenever we're doing a search in the database, we need to be able to say what feature that we're looking for things in. For example, clicking on the UK, we need to see all the events that are here. Thank you for checking out the feature loader and the features system as part of Tails. I hope you found it interesting, and see you in the next one.